Okay, let's start now. Well, let's start with number one. Number one. Okay, so use the distance formula to find the distance between P and Q. Number one, we have our P point. P is 4, 2, and Q is 8, 2. All right. So we have the distance formula is equal to the square root of uh, what am I napawasan dong? Okay, next we have 4, 8 minus, so x of 1, y sub 1, x sub 2, y sub 2. So x sub 2 is 8, 8 minus 4 squared plus 8 minus 4 and 2 minus 2 squared. So the value is 4 squared plus 0. So 16. The square root of 16 is 4. So 2 points each. Let's go to number 3. 0, 0, and negative 4, 3. When it is 0, 0, the distance is equal to the square root of. So directly, it is actually 4 squared and 3 squared. All right. So when it has 0, 0, 4 squared, and 3 squared. So that would be 16 plus 9, which is 25. So the square root of 25 is 5. Okay. Next, number 5. Number 5, we have square root of, number 5, we have 5 minus 0 squared. So 5 squared, I'll do it in shortcut way. So negative 6. So 2 minus minus 6, it will be 8 squared. So therefore, 25 plus 64, which you will get 89. So the square root of 89, I think that's square root of 89 already. But if you got it in decimal, so it would be 9.4. So that would be possible always. Okay. Number 7. Number 7, we have 42914. 42914. 42914. So when we get the distance, we just subtract 4 minus 9 is 5, negative 5. So that should be 25. And 2 minus 14 is 12. So that is 144, right? So therefore, the value is 169, which is, I think, 13. Right? So next, we got number 9. So that's another 2 points. 36AB. So 36 and AB. Number 9. 36 and point AB. So this is just an expression. So we will have 3 minus a squared plus a 6 minus b squared. So if you answer this, it's okay. If you answer this, 9 minus 6a plus a squared plus 36 minus 612b plus b squared. If you answered 45 minus 6a plus a squared minus 12b. If you answer this, it's okay also. Right? So both are considered correct. Number 11. Determine the following triangles with the given vertices of a... the given vertices are isosceles, right or neither, by finding the length of each side. So let's start by graphing, okay? So I'll insert a graphing template so that we can be able to check if this is a triangle. No, not this one. I see that. Pre-cal. Okay. So let's start with 11. So number 11, we have E -3, -2, X 1, -1, and P 0, 2. So let's graph this. So -3, -2, it's on the third quadrant. E -3, -2. We have 1, -1 on the fourth quadrant, and 0, 2. 0, 2 here. So that is P 0, 2. So let us try to connect first. We have to connect this one, and this one. Okay. So is this a right triangle or this is an isosceles triangle? So probably this is a right triangle. But let us start identifying first our distances. So let us assume that this is distance 1, distance 2, and distance 3. So let us get EP for distance 1. EP is the square root of, so 0 minus minus 3 is 3 squared, and 2 minus minus 2 is 4 squared. So this is EP, which is equal to square root of 9 plus 16, which is 25. So EP is 5. Now let's go to distance 2, PX. So PX is the square root of 1 minus 0 is 1 squared, -1 minus 2 is 3 squared. So that would be 1 plus 9, which is the square root of 10. Again, 1 minus 0 is 1, -1 minus 2 is -3, 3 squared is 9. Now let's go to distance 3. That is XE or EX. So we have the square root of -3 minus 1 is -4 squared, which is 16, and -2 minus minus 1, that would be 1, plus 1, which is 1 squared, which is 17. -2 plus 1 is -1 squared is 1. So -3 minus 1 is -4 squared is 16. So square root of 17. So we will try. So definitely the longest distance would be, since it is not an isosceles triangle, because no side is equal. So what are we going to do? We will apply the formula C squared equals A squared plus B squared. Now, since the longest distance is, I think it's 5, because the square root of 17 is 4 point something only. So therefore, we have 5 squared is equal to square root of 10 squared plus the square root of 17 squared. So that would be 25 equals 10 plus 17. So 25 equals 17. So they are not equal. So this is Neither. So who got this? 25 and 17. Who got it?
Me po, sir.
Huh? Shane, you got it?
Yes po, sir.
All right. Now let's go to the number 15 question. Number 15, number 13, right? That's only one question. Find the perimeter of each of the following triangles with the following vertices. Number 13, we have to find the perimeter. So 1, 8, 6, negative 4, and 11, 8. So no need for you to graph. So let's do it again. Number 13. So remember this. Okay, we will do it here. It's better. Number 13. So E is 1, 8. Next, X is 6, negative 4. And P is 11, 8. So we will be getting EX, XP, and EP. All right, so 3. Then we will add. So the distance EX, so distance of EX is the square root of, so let's do it. 1 minus 6 is negative 5 squared is 25. 8 minus 4 is 12. 12 squared is 144. So distance is 169, which is equal to 13. Distance of XP. XP is 6 minus 11 is 20, it's 5, so square 25. Negative 4 minus 8, so they are just the same, so 144. So distance is equal to 13. And another distance, which is EP, 1 minus 11 is 10, so 100. And then 8 minus 8 is 0, so distance is 10. So we have perimeter is 13 plus 13 plus 10, so which is 26 plus 10 is 36. Who got this correctly? Who got number 13?
Me, sir.
Me
Okay.
po,
Sir.
sir.
Here. Number 15. Let's go to number 15. So let's do it here. So number 15, we have EX again. It's the square root of negative 1 minus 4 is 3, so 9 plus 1 minus 3 is 4, so 16. So EX is 5. Next, XP. Square root of XP, negative 1 minus 3 is 7. 7 squared is 49. And then negative 3 minus 2 is 1, so 1, so that's square root of 50. Or 2 square root of 5 square root of 2. And lastly, EP, negative 1 minus 3. That's number 50. EP will be equal to the square root of 416, 1, 3, 4, 3, 9. So the answer is also 5. So the answer is 10 squared of 10. Perimeter is 5 plus 5 is 5 squared of 2, which is 10 plus 5 squared of 2. Or it would be what? 17.1. So either of the two is correct. Who got this? So 2 points each.
Me po, sir.
2 points each, and please record the score. DJ.
Yes po, sir.
Who got 30?
Really, sir? It's 30?
It's times 2, right? How much? 15? How many?
Sir, I think there's only
7
9
questions?
items. Wait.
Sir, the
Okay.
total is
It's over
16 po.
16 po.
15, right? You have how many questions? 8 questions. Okay, record the scores now, DJ.
Yes po, sir.
Record the scores so that you have your homework. Who got 16? Now let's go to number 16. Given 3 points, Q, R, 3, 1. Given 3 points, okay, show that they are collinear. So let us see and let us try to graph this number 16, okay? So negative 3, 4. So let's try to graph it here. Negative 3 and 4. Next, negative 1, 3. And 1, 2. Okay. So let us have QEI. QED. QED. So that's point Q, Q, E, D. All right. So let us get the distance. So let us a little bit erase this. We cannot erase that. All right. So distance 1, distance 2. So this point is negative 3, 4. We have also E, which is negative 1, 3. And we have also 1, 2. Okay. So let's get the distance of EQ. So to make it simple, EQ, distance is the square root of EQ. Negative 1 minus 3, so that's 2, 4. 3 minus 4 is 1, so 1. So square root of 5. Next, let's go to EP. EP is equal to 0 minus 1 is 1. 1 squared is 1. 2 minus 3 is 1, so 1, so that's the square root of 2. Let's go to QP. QP is negative 3 and 0, so that's 9. 4 minus 2 is 2, so that's 4. So square root of 13. So we will add distance 1 and distance 2, it should be QP. So QP is equal to EQ plus EP. So QP is square root of 13 and square root of 5 plus square root of 2. Do they have the same value? Square root of 13 is 3.6 approximately. Square root of 5 is 2.2. And square root of 2 is 1.4. So 3.6 is equal to 3.6. So therefore, they are collinear. Okay? So they are equal. Square root of 13 is equal to square root of 5 plus square root. Is it clear? Is this lesson is simple? So this is included in your exam, okay? So this is the same with number 17. Okay, let us try number 18 for the last question. So let us insert again a graphing template so that we can be able, I think here we can add it here. So what are the points? 18. Cute. So parallelogram cute or quadrilateral CUTE are congruent for the diagonals, okay? Then show that the diagonals. So 5, -1. Let us try 5, -1. 5, -1. 5, -1. And then we have 9, -1. 9, -1. 9, -1. That is U. And then we have 9050. 9050. That's too small. 5090. Okay, so we know we should check if the diagonals are equal, all right? So this is the parallelogram, the quadrilateral. This one, this one, this one. So the diagonals of a quadrilateral is located this and this. If they are equal, then it is a rectangle. So EQ. So let us see EQ. And also we have, that's EQ, EC, right? EC. This E and C. So C is at 9, -1. Is this one, 9, -1. Okay, so 5, 0, and 9, -1. So 9 minus 5 is 4. So 16. -1, so 1. So EC is the square root of 17. Now let's go to, what's this? So let's try UT. UT. So we have 5, -1, 9. So 9 minus 5 is 4. So 16. And then, why they are not equal? This is 5, -1, and 9, 0. That's 9, 0. So that's 1. So 17. Are they equal? Yes. So this is a rectangle. Okay. So any question? So
No
this is
question.
included in your exam. Okay. Distance formula is easy. Determine the quadrilateral ABCD's vertices of a parallelogram. So this is also easy. If the diagonal opposite sides are equal, then it is a parallelogram. Okay, so that will be all. You have any question? Any question about